area under simple curves. In application of integrals, area under simple curves is a very important part. Let's start area under simple curves by drawing a rectangle over here. So I have a rectangle here and I'm asked to find out what is the area of this rectangle. So to find out the area of a rectangle, you just need to, suppose I'm shading the entire area here, and I have the length and breadth. I can easily find out what is the area of this rectangle, right? What is it? It is nothing but the length multiplied by the breadth. So length into breadth will give us the area of a rectangle. But what about a curve which is looking something like this? Instead of a rectangle, I'm drawing a curve which is looking like this. What will be the area of this particular graph? Now, to find out this, I can use integration, right? So how can I use integration here to find out the area of this curve? Suppose I draw the axis over here. So I have drawn the axis, x-axis and the y-axis. And I can see that this curve over here has an area. Like suppose I take this curve as a pool or something. So this pool is looking like this and I need to find out the area. And how can we use integration to find out the area of this particular pool or particular shape? So let's look at a simple graph first of all. So I have a graph over here where y is equal to f of x. So here y is equal to f of x and I need to find out the area of this y is equal to f of x, the simple curve. So and the boundaries are given from here a and here b. So how do we find the area? We just take this entire thing over here, that is the function y is equal to f of x, and integrate from a to b, that is integrate a to b f of x dx. Now what is this f of x? It is nothing but a to b y dx, right? So this is how we find out the area of this particular curve, that is y is equal to f of x. And this curve I have taken the area with respect to which axis here? I have taken with respect to the x-axis. Remember, I have taken here with respect to the x-axis. Suppose I have another curve over here. And this curve is looking something like this. And I need to find out what is the area of this curve. Now here what I'm going to do here is I'm just going to take out this graph's area under which axis? The y-axis. So here y is equal to f of x, the graph is y is equal to f of x. Now I'm going to find out the area of this particular graph under which one? The y-axis over here. So to find out this area over here, I cannot use integral a to b. Suppose this is a and this is b. I cannot use a to b f of x dx. That is wrong. Because now here it is based on which axis? It is on the y-axis. So what happens is I need to take integral a to b. This is wrong. So I need to take integral a to b. Instead of y dx, I need to take it as what? X dy. Now using this x dy, that is integral a to b x dy, I can easily find out what is the area of this particular graph. Understood? So these are the two different ways in which you find out the area under x-axis as well as the y-axis. Now let's look at how to find out the area of a particular graph. So I have drawn a circle here. Now, how to find out the area of this particular circle using the integration that we just studied. So I'm taking here this point as a comma 0 and this a is given here. So what will be this point here? It will be 0 comma a, this will be minus a comma 0 and this will be 0 comma minus a, right? So these will be the corner points of the particular circle. Now to find out this area of the circle using integration, so what I'm going to do is I'm just going to put the origin over here. So I am not going to find out the entire area right now. What I'm going to do here is I'm just taking the area of this particular quarter over here, or the quadrant we can say. So that quadrant is having a curve like this, right? Yes. And what will be the equation of this particular circle? Since it is having the center at the origin and having a radius a, I can say that the equation of the circle is x square plus y square is equal to a square. So that is the equation of our circle. Now to find out this area, this quadrant's area, what I'm going to do here is I can use either integral a to b f of x dx, right? I'm taking with respect to which axis over here? I'm taking with respect to the x-axis. So when I take with respect to the x-axis, I can use integral a to b f of x dx, right? Yes. Now, or also we studied it is integral a to b y dx. Yes. Now, According to the equation of the circle, that is x square plus y square is equal to a square. From that, what you can deduce? You can say that y square is equal to a square minus x square, or y is equal to root of a square minus x square. So we have got what is y. So this is the curve here. It is y is equal to root of what? A square minus x square, right? Yes. Now what happens is I need to find out the area using the form that we just studied, that is integral a to b f of x dx. To find out the area of the first quadrant, what is a here? The initial point, it is 0. And what is the final point position? It is a. So instead of a to b, it will be 0 to a integral y dx, or it is nothing but 0 to a root of a square minus x square dx. So now if I integrate this integral 0 to a f of x dx, or integral 0 to a root of a square minus x square dx, so here the area, the integral will be, that is the root of a square minus x square, the integral will be x by 2 root of a square minus x square plus a square by 2 sine inverse x by a. And what is the limit here? 0 to a. So when you apply the limit here, you will be getting a by 2 root of a square minus a square, that is 0, minus 0 also when you put here, he will be getting it as so much 0. So this upper limit and lower limit will give us 0 minus 0 here. Then you put a here, you will be getting a square by 2 sine inverse a by a minus a square by 2 sine inverse 0 by a. So what will be the final answer that you will be getting? You will be getting it as a square by 2 sine inverse a by a minus a square by 2 sine inverse 0 by a. So here you will be getting it as a square by 2 sine inverse 1 by, or a by a is 1, that is pi by 2. So a square pi by 2 into pi by 2 minus this part will be 0, and the final answer will be a square pi by 4. Now this is the area that we got. What is the area of this one? It is a quadrant's area. A circle has how many such quadrants? You have 4 such quadrants. So what will be the area of the circle? Will it be 4 multiplied by the area that we just got? Yes. So 4 into a square pi by 4, or it is nothing but pi a square. So what we have found out here is nothing but the area of the circle using what? The integration, that application of integration that we have just done. So we found out the area of the quadrant, then we multiplied it by 4. Why? Because there are 4 such quadrants. So you multiplied it by 4 and got the entire area of the circle. Now, there is another thing I just want to ask you. Suppose you have a circle, like this, and then you also have another line over here. You have a line over here. And the equation of the circle is given, actually the equation of the circle is given as x square plus y square is equal to a square, and the equation of the line is given as y is equal to x. And they are asking us to find out the area which is enclosed between the circle as well as the line, that is y is equal to x. How can I find that? So you know that when there are 2 curves or 2 lines or whatever, when they intersect each other, there will be always an intersection point. So here as in the figure, you can see that the circle and the line are intersecting. Yes. So there will be intersecting points. And what is the intersection point? So you have to first find out what is that intersection point. So what the intersection point from the equation, that is x square plus y square is equal to a square and y is equal to x, we will be getting that as x square plus y square is equal to a square. In place of y, you can put x. So you get x square plus x square is equal to a square, or 2x square is equal to a square, x square is equal to a square by 2, or x is equal to a by root 2. So that is x. X is what? A by root 2. So x is equal to y. So you can say y is also equal to what? A by root 2. So I can mark this point as a by root 2 comma a by root 2. So that is what we got here, a by root 2 and a by root 2. Now I need to find out the area which is enclosed between this curve and the circle. So what will be that area? I am shading it over here. This will be that particular area. How will we find that? So look here, as you can see, this area that I have just drawn here, if I just take it like this, I can see that till here, from the 0 till this intersection point, it is in the shape of a line, right? It is in the shape of a line, or it is enclosing a triangle over here, right? So this part over here is enclosed as what? A triangle. The remaining part over here, as you can see, if I just mark, it is not enclosed by a line, but it is enclosed by what? The circle's arc. So this entire area, if I want to find out, I just need to use 2 different ways. That is, From 0 to this meeting point, that is a by root 2, it is a line. And from a by root 2 to this point, that is here, it is a0, because the equation of the circle is x square plus y square is equal to a square. So this end point here is a comma 0, right? So from 0 to a by root 2, it is enclosed as the line, plus from a by root 2 to a, it is what? The circle, right? Yes. Now what will be the final calculation that we have to use here to find out the complete area? So we can just find out that. So what is the equation of the line? It is y is equal to x. So from 0 to a by root 2, it is y dx, plus from a by root 2 to a, it is the circle's y. What is the circle's y? It is y square is equal to a square minus x square from this one, and y is equal to root of a square minus x square. So use that, you will be getting root of a square minus x square dx. What is y here? Y is equal to x. So you can put 0 to a by root 2 x dx plus a by root 2 to a root of a square minus x square dx. What is the integral of x dx? It is x square by 2 from 0 to a by root 2 plus root of a square minus x square. The integral is x by 2 root of a square minus x square plus a square by 2 sine inverse x by a. And that also from the limit a by root 2 to what? A. So when you apply the limit, that is x square by 2 from 0 to a by root 2, I will be getting that as a square by 2 minus 0 square by 2. Yes, that is the first one. Plus when I apply a here, I will be getting a by 2 root of a square minus a square plus a square by 2 sine inverse a by a. Yes. And when I apply the lower limit, that is a by root 2, I will be getting a by 2 root 2 the root of a square minus, what is a by root 2 square? It is a square by 2, and inside it will be a square minus a square by 2 is a square by 2 itself, plus a square by 2 sine inverse a by root 2 by a. So that is what we get. So this one here over, I will be getting a square by 4 plus a by 2 root of a square minus a square will be again 0. So that goes, plus a square by 2 sine inverse a by a, it is a square by 2 sine inverse 1, which is pi by 2. So that is written here, minus a by 2 root 2 into a square by 2. What is a square by 2's root? It is a by root 2. So when you multiply that, you will be getting a square by 2 root 2 into root 2. That is nothing but a square by 4 plus a square by 2 sine inverse. You have a by root 2 divided by a, that is sine inverse 1 by root 2, which is nothing but pi by 4. So you have all this. So when I open the bracket, I will be getting a square by 4 plus a square pi by 4 minus a square by 4 minus a square pi by 8. So this a square by 4 gets cancelled, and a square pi by 4 minus a square pi by 8, if I just multiply, I will be getting it as a square pi by 8 itself. So this a square pi by 8 will give us the area between what? The line and the circle, that is enclosed between the line and the circle here. So I hope you have understood how to find the area between of a circle using integration, and also how to find the area of a line as well as what, which is enclosed by a circle also. Now suppose instead of a line and circle, if I am drawing a circle over here, and suppose this is the axis, and there is another parabola or something which is going like this. So you have a circle and you have a parabola. So what about the area which is enclosed between these two? Suppose I mark this area over here like this. How can I find the area which is enclosed between this parabola and what? The circle. How can you find that? You will learn that in the next session. Until then, keep exploring.
Manorama Horizon. Learning made simple.